Dear students, today we have learned real numbers, 10th standard, and that one very important 2 marks topic. That one is the question like that given. That is prove that root 3 is irrational. So in this one, you have to write the solution. Let us assume root 3 is assume to contrary that root 3 is rational. Root 3 is rational. Now, I'll write in this one, that is root 3 is equal to a by b. Cross multiplied, we get b into root 3 is equal to a. So let we have doing for here, a and b are co-primes, where b is not equal to 0 and a and b are the positive integers. Actually, a and b are common factor other than the one. Then we can divisible by the common factor. That means we can make the for this one squaring on both sides or rearranging we can get on. So that is squaring on both sides we get b of root 3 whole square is equal to a square. That is squaring on both sides. Now I have to write this one. Also rearranging we get b square. This one become 3, that is 3b square is equal to a square. So therefore, it can be represented as, this can be represented as a square is divisible by 3, divisible by a 3, and also we can say as a is also divisible by 3. So this one to have to write by 3. Now I have to take here you can written as another one. A is equal to, let A is equal to 3c. Actually, c is integer. C is some integer. So that's why c is an integer means z. Or we can write I. Substituting for a here, what is a here we get b squared. Okay. Instead of a square we can write squaring on this one. A square is equal to 3c whole square. We get a square is equal to 9c square. Instead of a square, here a square means it is 3b square. You substitute here 3b square is equal to 9c square. Then it means that b square is also divided by 3c square. So actually divided by 3 on both sides here. We get b square is equal to 3c square. Now it can be shows that we can written as, therefore we can written as b is also actually b square is divisible by 3 B is divisible by 3. B is also divisible by 3. Okay. So by using theorem. Then after we have to write. Therefore A and B have at least 3 as a common factor. But this contradicts the fact that A and B are co-prime. This contradiction arisen because of our assumption that root 3 is rational. Therefore, we conclude that root 3 is rational. Like that, we have to prove.